You can see the topic,
Yep.
and let's dive right in. First of all, a little bit about me. Um, uh, I am an engineer. It's not just what I do, it's who I am. It's the way I think. And I engineered professionally for Bell Labs for 40 years. I recognize a couple of familiar faces out there. I see Bill is smiling, yeah.
Yep.
Um, and I worked on computers and data communications and computer networking for Bell Labs. I decided sometime around the time I was 15 that I wanted to work with computers, and I have kind of been doing it ever since. Um, so computers are part of me. As for the sports, I have always enjoyed sports. I'm much more an engineer than an athlete, but um, I enjoy sports, and I'm enough of a good student that I can get vaguely competent at a sport that I set my mind to. There are some that I can't. I'm sure that I'll never be any good at all at basketball because it requires too much split second work and not enough things that you can practice. And golf, on the other hand, is really nice because if you practice it right, you can get reasonably good at it. I've been involved in a bunch of sports over the years, and sometimes when I get involved in the sport, I uh, I get involved with computers or the technology of the sport, and that usually involves computers. So let's go back to 1970 or so when I was involved in sailing. I raced sailboats, and uh, in sailboat racing, there's a very important part of the boat called a centerboard, which keeps the boat from slipping sideways in the water. Um, and the boat that I started out racing had an aluminum centerboard, and according to the rules, it has this red centerboard. It's a thin aluminum plate, and it does not do a great job. The first competitive regatta I trailed my boat to, we came in like ninth out of 12 boats, and all the last four boats all had aluminum centerboards, and none of the others did. So that's got to tell you something. That's a strong statistical statement. And I was told you really want to get a wooden board. So I started researching centerboards because I'm an engineer, that's who I am. And I found out that a thin plate, and you notice it's set at an angle, it's going to be moving this way through the water. So it's like the water is going this way over the centerboard. This thin plate causes the water to break up just about as soon as it gets to the low pressure side of the board. And so I looked at what would happen with the wooden board, and this is the shape of most of the wooden boards in the sailboat class that I raced in, and it did a whole lot better. The water got back around here or here before it started breaking up. Then I found out that there's an organization called NACA, um, and they did airfoils, designed airfoils, tested airfoils for aircraft, and a whole lot of that is transferable to water. And I found out that they had a standard section. This is the green, where water did nice flow over it, and that gives you a really good lift to drag ratio. Uh, and I said, okay, this is the surface is described by a fourth order polynomial plus a square root term. So let's see we can do. And what I could do, we had a small computer. It was more like a huge programmable calculator in our lab in Bell Labs. And we also had an HP flatbed plotter. And so I programmed that equation, had it plot the curves on the flatbed plotter on a piece of hardboard. Anybody use the red fiber board that they use to cover reports? That is really tough stuff. We plotted it on that. I took a knife and cut out the section to use as a template and made myself an NACA airfoil centerboard. And immediately I showed up with the centerboard at the nationals and took third place in B division. So all of a sudden, people knew that there was something that could be done with a centerboard. And for the next several years, nobody won an Albacore National Championship without borrowing my templates and making their own centerboard. So computer technology worked for that. Let's fast forward to the relatively early 1980s, probably 1984 or so. The IBM computer had just come out. And being a computer type, I went out and built myself an IBM clone. And back then, you didn't buy a motherboard, you bought a printed circuit board, a bare board, and soldered ICs to it. And I did that. I built myself a PC and said, okay, I've got one. I'd like to program something on it. What sort of good programming software is there? None of the stuff that Microsoft made was anything that interested me. It was too much swapping of diskettes back and forth. But Turbo Pascal came out, and you will see from the floppy there that I got my copy of Turbo Pascal towards the end of 1983, real early in its life. That's serial number 1028 of Turbo Pascal 1.0.
Wow.
And that was a really neat, a really neat package. Didn't occupy much memory. Everything lived on one floppy. You could load it from one floppy. It had a integrated development environment, the first one I ever saw. And that was wonderful compared with anything I had done programming before. And I went ahead and threw together something for my then current sport, which was bicycling. By that time, I had kids, and things like sailing and skiing took too much time, but I could always get off for a bicycle ride. Bill Chris is probably smiling because I sold him my my second bicycle to get my third bicycle. So this is sort of a spreadsheet for designing your gearing in the bicycle. This was for a 5-speed. I later expanded it to not a 5-speed, it's a 10-speed. 2 sprockets in the front, 5 on the rear, and you could go to it. Hello? So somebody say something? Okay. You can go to 3 front sprockets and 7 rear sprockets and get a 21 speed. But these dots here, okay, so this is basically a spreadsheet for designing your gearing so that you don't have any doubling. Notice that none of these dots are at the same gear ratio.
Yeah.
If you aren't careful about how you choose your sprockets, you can get doubling, which is usually not a good idea. This is a very common recreational gear ratio. For racing, you typically have a whole bunch of the dots down at the bottom on this side and up at the top on this side. But you can design your own gear ratio and see by the dots what it looks like. So that was my contribution of computers applied to bicycling. Now, I've in the invitation, I put down an outline of the things I want to cover. Here they are, and we're going to start with how computer networking got my name and my reputation and my knowledge out there to start this. And to understand that, we have to understand what the computing environment was like when I got back into golf. I had golfed as a kid, stopped to raise kids, and start my career, and got back into it at around age 45. And what you had in the early 1980s was only one golf forum anywhere in the world. Well, anywhere on net news, anywhere on the internet. Net news was the forum site for the internet. There was no such thing as a browser until around 1990, and browsers weren't common enough so that people figured out how to put forums on browsers until the mid to late 90s. So what you had was net news, and it was the only game in town. It had a hierarchy. For instance, there was the comp sub-hierarchy. There was the recreation sub-hierarchy. There were others as well, but I spent most of my time on comp and rec. And working down recreation, sport, golf. So rec.sport.golf was the hierarchical name of the only golf forum on the internet. And I spent quite a bit of time there. About that time, my kids were getting to be teenagers, and I thought it would be nice to introduce them to golf. But at that point, they're growing like weeds. So I didn't want to spend a lot of money on a brand new set of golf clubs, and then 6 months or 12 months later have to get the next set up because they had grown out of them. So what I would do would buy used sets of golf clubs, typically at garage sales, and modify them. Well, there was lots of stuff out there, books and pamphlets and companies that would send you material on how to work on golf clubs, but nothing that told you about how to engineer them, what you really wanted it to look like when you were done working. So I had to kind of start doing research on that myself. And of course, I love that because I am an engineer and that's the sort of thing I do. And anytime that I found something interesting about the engineering of golf clubs, I would post it here on Rexport Golf. Now, that went on for some time. And I had done a bunch of interesting things that I had posted about. And sometime, I guess it was 1995, I started seeing this this ad on my TV fairly frequently.
Moving out there. Something turning bogeys into pars, pars into birdies. TaylorMade's burner metal wood with the bubble shaft. No, it doesn't look like anything you've seen before. But then again, neither will your drives. Capture the power. There's something out there. Something turning bogies into pars.
Oh, come on, guys.
TaylorMade's burner metal wood with the bubble shaft. No, it doesn't look like anything seen before.
Okay, I'm gonna have to get rid of this somehow.
Neither will your There's the power.
You can just X out the VLC player if you want.
Here we go. Okay, I had to move the co-host's taskbar. It was covering up my my kill. Anyway, I saw that commercial and thought it was kind of over the top, and posted something on Rexport Golf about how it looked like at TaylorMade the marketing department had kind of taken over, and immediately got a response, believe it or not, from the director of R&D at TaylorMade. As I said, there's only one forum for golf on the internet, and so he monitored that to see what they didn't have the term going viral at that point, but see what went viral on the internet. And he saw my post, and he took exception to it and said, no, this is all sound logical ingenieering, and threw in a whole bunch of engineering buzzwords that he was hoping, I think, would intimidate people. And I looked at them and I said, this isn't about the flexibility of the shaft, which is what I thought they were talking about. It's about the weight of the shaft. So I thought to myself, is there something that we can do to mess with the weight where the word bubble might work? And this picture on the top was the model I came up with, where you have a shaft, the red cylinder, and this mustard colored thing is a bubble of mass, a weight that we were going to find an ideal spot for along the length. And I came up with a very simplified model of clubhead speed, which is how you get extra distance, and just just programmed it into my computer. At that point, I had of course, a personal computer and various languages by 1995. So I put together something. Actually, the ideal for this would have been a spreadsheet, but I didn't have that on my computer yet. And anyway, the rows here are the mass, what fraction of the mass you're going to put into the bubble. And the columns are where along the length of the shaft are you going to put the bubble. And I just plotted it to see what would happen. And most of them, with zero mass in the bubble, you had, say, 100 miles an hour club head speed. That's a fairly good club golfer. Nowhere near tour, but nowhere near old guys like me either. So 100 miles per hour is a pretty good club head speed. And it tended to drop off for most of these boxes. But somewhere around the middle here, we had an extra half a mile per hour of club head speed that was gained. Now, that isn't enough to make a big difference in distance. Probably would make maybe 2 yards of extra distance. but it's enough so that the advertising department can say with a straight face, we've made this club longer. You can hit it further with this. And anyway, I printed out the result, well, printed it to a file that I emailed to the director of TaylorMade's golf. He said, he wrote back almost instantly. It took my engineers 2 years to figure that out. You figured that out in a few weeks. Do you want the job? Now, if you recall the 90s, the dot-com had not bubbled yet. It was probably the most lucrative thing you could be in. Plus, I was enjoying it. So I turned down the offer of a job because it would have required a massive pay cut. But it did convince me that I could probably have a promising little consulting business if I ever retired. And that, in fact, is what I started to do. So when I retired, I discovered that computer networking gave me an enormous collaboration tool with people all over the world. By that time, browsers were fairly common. There were a lot of people who had the internet, not just a few, and it reached all over the world. It wasn't just a U.S. thing, which it was in it was almost completely U.S. in the 80s. So let me cover a pair of these bullet points with one item. It's allowed me to collaborate. And also, it's allowed me to develop computer programs for other people to use on their computer to help them with their golf. I'd like to break out again and give a demo of a program that I developed with somebody in Germany. Now, I have never met Frank Schmidberger. I have not met him in person. I have not met him on a video call, not even a phone call. But with email and with email file transfer and some interesting servers that we had, we co-developed a program. Let's see, I've got it up already. Okay, here we go. It's called TrajectoWare Drive, and it plots the trajectory of a golf ball. If you feed in the right things. Now, one thing you could feed in this column here is impact parameters. That's what is the golf club head doing just before it hits the ball. And these are launch parameters. What is the ball doing right after it leaves the club face? And we can, if you notice, if I change the loft of the club, you'll notice that the launch parameters change because I'm changing what happens to the loft. What you can't see is I'm actually modifying these parameters just by rotating my my scroll wheel on the mouse. I could also do it by hitting the up and down arrows on my keyboard. Neat user interface. So Frank programmed the user interface. I programmed the engine that calculated the trajectory, and also the engine that was able to go between impact parameters and launch parameters. And by the way, if you want to change the launch parameters, you'll see that it works back into the impact parameters as well. Almost no programs work backwards, and there certainly aren't any that will watch what happens to here is the trajectory. Watch what happens to the trajectory as I, for instance, change the loft. You can see it peak. You can see the distance peak, and as it goes higher, it starts to lose distance. So this is the only program that does trajectories that I've seen where you can move it in real time. Also the only one where you can change the impact parameters by monkeying with the loft parameters, the launch parameters. Yes.
Dave, can I throw a question in there for you?
Okay.
Okay, how about a play? In the chat. I'm going to paste an image, and only because it's come up in the past with my kids, talking to them, and with others when they're going out. Loft doesn't mean anything to them. You know, it's golf, loft,
right.
You know, the terms.
Okay.
But the concept of, you know, the whole thing with golf is a sport of opposites. You want the ball to go far, you're hitting a lower number club. You want the ball to go up in the air, you got to hit that, you know, things like that. So I just sent you through the chat an image with the loft angles, the loft measurements of irons.
Let me do better than that.
Okay.
I want to show you another feature of this program, and that is if I go over here to the upper right-hand corner and click on the question mark, I get the complete manual. Now you want to know about loft, so let me, I won't even scroll down in the index. Let me put in the search. Loft, and it gives me immediately the thing to click on, and here's a picture. Let me grow it. Here's a picture of loft.
Okay.
It's the slant of the face. So the loft is the face direction. It's got a definition of dynamic loft and everything that can affect it. So we have a health facility that has all of these things in it. Now, you sent me a list of the lofts of irons.
Right. And well, the idea was like talking to, like, I remember going out with my son, and, you know, look, your club head speed is going to be your club head speed. You're not going to have a dramatic impact, a dramatic increase or decrease in your swing speed. What will change is going from a 9-iron to a 5-iron. The same club head speed, the ball's going to go further with a 5-iron than a 9-iron, but it's going to go higher. So that kind of thing, where you can put in the loft angle and see that, okay, a 5-iron is 27 degrees and a 9-iron is 42 degrees. So you compare the ball flight and the distance between the two of them. And rather than dear old dad with a cup of coffee trying to say, well, this is what's going to happen, they can look at it on a computer screen and say, oh, wait a minute, this is what's really happening.
Can everybody see, is this just on my screen or can everybody see what?
I can see it.
We see it, Dave.
Okay, this is what's been put on the chat, and it shows how a 2-iron, which is a fairly long club, has an 18.5 degree loft,
Yeah.
and it's going to hit the ball a long way. And the 9-iron has a 42 degree loft, more than twice as much, and it's not going to hit the ball nearly as far. Back when I had a 2-iron, I could probably hit the 2-iron 200 yards, and a 9-iron I could get maybe 125 yards out of it, 130 yards. So
But if you could put in the number there, 18.5 and the 46, and see the difference, because you're not changing the swing speed, right?
yeah, and let me just show it with woods. I can't show
Okay.
irons, and I'll get to that in a second. But let's go make this 100-mile-per-hour clubhead speed, and we'll just do a level hit, that 0 angle of attack, and we'll make the loft. We'll make the loft 10 degrees. Actually, let's make this a higher clubhead speed, 120. So you'll notice that the carry distance is 291 yards, and you can see it on the graph as well. And we can click for a new trajectory, starting out the same, and let's put more loft on it. Let's crank the loft up. And as we crank the loft up, you can see the carry distance is reducing. You can see the new one going higher and not as far.
Yeah, sure.
So that probably illustrates what you're talking about.
Exactly.
Okay. And to a limited extent, this can do it. Now, I say to a limited extent because let's go back to the presentation. There were limitations that we knew about and some that we didn't know about. And one of the limitations is the aerodynamic model that we were working with has spin limitations. You really can't model irons. A 2-iron you can, because it's almost not, as a matter of fact, nobody uses 2-iron anymore. They use metal woods with that sort of low loft. But this was intended to model drivers and long woods, and we knew that the aerodynamic model fell apart if we put together too much spin. You put a wedge in, and it's sort of like it goes straight up in the air and comes straight down. Starts out in a good direction, but it balloons and it drops almost straight down. It's just a totally inaccurate way of modeling that. And some of the things that we knew that we were building in limitations were the aerodynamic model. We only have carry distance. We don't have any bounce or roll after it lands, so we can't give total distance. and it only runs on Windows. And that was fine for Frank and me. We were just doing something for our own amusement and our own use, and we sort of made it product quality simply because that was the habit that we both have. But neither of us was an Apple user. Neither of us was a Linux user. We both knew how to use Unix, but we didn't have Unix machines at home. So we built it for Windows. And we said, if we have enough users and we have to issue a bug fix release, we might want to change some of these things. Good news or bad news, it's been 20 years. We're still on version 1.0. There was never a bug found by us or reported by users. How the hell does that happen? Let me tell you how it happens. The two programmers I worked for Bell Labs, which designs software that's got to work 24/7. So we know how to find bugs that might cause a program to crash. And Frank was a programmer for a Swiss bank, which doesn't want any kinds of errors at all. So we, between the two of us, we knew the techniques to wring errors out of the software. We set up
I think it's because you didn't accept advertising.
That's a good angle, but no. What happened was we set up source control, we set up a bug reporting system, all the things that I almost suspect that most phone app development companies don't even bother with, based on my experience with phone apps. But we did it the right way. We have never had a bug in the 20 years. Now, we had some missed features. Some of them we knew before we started were limitations. There were some that we didn't anticipate as well. Is it Andy who's the golfer?
Yes.
Yeah.
I try. I'm not going to plead guilty.
Yeah. A lot. This was done in 2006. Somewhere around 2010, a gadget called TrackMan, a launch monitor, came along that used radar to track the ball and to tell you what the clubhead was doing. So it would come in with the impact parameters and with the launch parameters and track the ball, and it could give you all that, including the entire trajectory. So TrackMan got very popular with researchers and eventually with even instructors. Every school of golf, all the indoor golf places, they all have launch monitors. And very often that launch monitor is TrackMan, which started it. Now, TrackMan had naming conventions. They had names that they gave to parameters. They have pluses and minuses representing left and right, hook and slice. And some of those conventions are different from what we did for TrajectoWare. And the entire world has adopted TrackMan. So we have some misleading names and some bad sign conventions that we would like to fix if we ever get around to a version 2. The golf ball aerodynamic model has changed radically because golf ball aerodynamics are just so much better. They put on 20 or 30 yards since in the 20 years that we're talking about. Also, part of impact is something called gear effect, which we did not allow for. There really wasn't a simple mathematical model for it in 2006. So these are all things, if we get around to a version 2, we would like to do. But without bugs to fix, we're not strongly motivated. As a matter of fact, Frank said, I don't want to do this anymore. You can do it. So it would really be a start over because Frank had the tools at the time to do the framework and the user interface. I don't, he doesn't anymore. So we would have to start the whole thing over to take care of this. It's still supported, just barely. I get about 3 requests a week for it. And yeah, I give them download privileges. So that's where that is. Move on to the next bullet.
Dave, how does your price compare with TrackMan?
Excuse me?
How does the price compare with TrackMan?
If we charged for it, that would be an interesting question.
Yeah.
Dividing by 0 does not give meaningful answers. TrackMan is $20,000 or $25,000.
Yeah,
okay.
It's not for the casual weekend golfer.
No, but it has become essential for anybody who's going to call themselves a serious instructor. That's got to be one of the reasons that golf lessons have gotten expensive.
Yep.
Okay.
Where's the other golfing pool? Mike Rowan, looking to hear from you, Mike. You've used that kind of stuff before.
No, I only used the distance, watch.
I have one of those. Those are cheap. Those are
I used to have one that you had to download. You could only download 10 courses at a time.
Oh, that's a simulator. That's
Sky Tracker, whatever it was called. But now I have a watch that was pretty reasonable, and it knows where I am, and it knows how bad I play.
Yeah, SkyTrack. I know the guy who did that. Yeah, I also know the guy.
Sky Caddy. Yeah. Yep. And it was a pain in the neck because I had to, we play at 8 different courses, and I play at 5 other different courses here, and you could only have 10 courses on the thing at a time. So I had to keep changing, and it was a horrible interface on the computer and took forever. And the little clamp that hooked onto it was terrible. And
actually, about that time, I was on a project to do something similar to that. And we didn't get out in time. There were like 3 others.
Yours would have been better, I'm sure.
I would like to think so, but we never got out to market. Okay, another thing I do is that I use the computer for in my golf technology is the quantitative part of my R&D. And I have put together some one of the things that I did, but I think we're going slow, so I'll skip over this real quick. I mentioned that gear effect was part of the impact. This is a picture that shows what gear effect is, and it affects the spin of the ball. If you don't hit it in the middle of the striking face. If you hit it on the toe, it'll give hook spin. On the heel, it'll give you slice spin. And around 2009, 2010, I put up uh, I think it's interesting anyway, mathematical model, simple mathematical model for calculating the gear effect spin. And it has generated a certain amount of discussions and arguments about things. And I think it stood the test of time fairly well. For instance, around 2012, Jeff Summit, who was the chief designer for Hirico Golf, had a wonderful idea for how to move the center of gravity around in the golf club, in the head of a golf club. The designer can move it. The golfer can't, but the designer can move it on the drawing board. And he wanted to know, well, I can do this. Where should I move it? And I gave him a spreadsheet based on the mathematical model that allowed him to design it, and resulted in my favorite 3-wood of all time. So I think he did a good job, but it feels good that it was my stuff that made it work.
That's great.
What were the 3 words?
What? Oh, I said 3-wood. That is a club. I'm not sure how to get me back to on screen. John, how do I do that? How do I come?
We're looking at your face.
Stop sharing the screen?
No, you don't have to.
Looking at you.
Okay.
We can see you as the speaker. So if you just hold something up,
yeah, there you go.
We'll hold it.
Okay. This is my 3-wood that Jeff Summit designed.
Oh, 3-wood. Okay.
Okay.
Want to hold that up again? Do you still have it there?
Yep.
And what's the loft on that?
14 degrees.
Okay.
That's it's a degree lower than a typical 3-wood and probably 2 degrees lower than an easy to hit 3-wood. But
great.
But because Jeff was able to put the center of gravity so close to the sole of the bottom of the 3-wood, it behaves. It's still almost as easy to hit as a 16 degree.
So it's what they would call a strong 3.
That is exactly what you would call it. It's 14 degree would be a strong 3. Now, gear effect came back in a kind of exciting way a couple of years ago. I don't know, the golfers among you will probably recognize this commercial.
Maltby?
LA Golf. Oh no, Bryson's busy. The DJ's always available. Welcome to LA Golf. You guys ready for tour? We're the only golf company that manufactures clubs here in the United States. All LA Golf drivers are built right. LA Golf, apparel, contest.
By the way, the guy who keeps showing up is Bryson DeChambeau, who is a
yeah, we know who he is.
Okay.
At least I do.
He is one of the biggest hitting competitive golf pros there is.
And he's quite the enigma. All his clubs are the same length. All his irons are the same length. Or they were at one time.
Yeah.
Yeah, that's his claim to fame. And Mike, just to throw it in there, for those that are where I was not too long ago, where you can spell golf. Typically, the shorter irons, what they call the shorter irons, higher number, is a shorter shaft. A longer iron, like the wood that Dave was showing, has a longer shaft. That's for 99 plus % of the golfers out there. That pro golfer that Dave just showed, Mike was talking about, is the only one that I'm aware of where every one of his clubs is exactly the same length.
Every one of his irons. It's every one of his irons. His woods are longer.
Yes. Excuse me.
And I have a single length iron set myself. I like it.
You got to go on TV.
I can't hit the ball the way he can, and
none of us can.
I don't even want to. When I try to imitate a swing like that, I hurt myself.
Yeah.
But Bryson's real claim to fame is he is probably the only competitive pro out there whose degrees are not in something like phys ed or business. He has a major in math and a minor in physics, or maybe it's the other way around. He knows what he's talking about when it comes to technology, which none of the other guys, nor do the commentators on TV know what they're talking about. They will.
So what's Scotty Scheffler doing right, Dave?
What is he doing right?
Everything.
A lot of really good practice.
Okay.
He's a really good athlete to begin with. He's been doing this since he was really young. It's all falling into place for him. And as far as, well, okay, it's off topic and I don't want to go there yet, but I think I understand why he slides his foot too. Has to do with the weight shift and the fact that he is a good enough athlete to get away with that.
Yeah, nobody else does that, really.
Nobody else does, but a lot of them go up on one toe. You watch Rory, he'll go up on one toe. That shows that he's shifting his weight. Scotty just lets his weight move forward and doesn't worry about balancing on one toe. He just lets the foot drag. That's my theory about it anyway.
Well, it worked for him.
I showed the LA golf commercial with Bryson, and what I was getting at was about a year before that, I got a phone call from one of the guys in that video, the chief of engineering for LA Golf, who told me that they are designing a new driver for Bryson because he's unhappy with the company that he's with. And he thinks that his problem with their driver is something to do with gear effect. And since I had come up with a model for gear effect, could I talk to Bryson and see if that's what it is, and talk to them about what they might do to do things differently. So I spent a half an hour on the phone with Bryson. And yeah, he knows what he's talking about. It's a pleasure to talk to him when you're talking technology, because there are few people in golf who have made that much of a study of it. And when he was done, I thought that there were things that LA Golf could look at to improve their gear effect. And yes, I told them what that was. I gave them a report, suggested their engineering staff looked at this, that, and the other thing. And one of the things was the curvature of the face, the club face, and is the right amount of curvature for Bryson's clubhead speed. And a year later, when this commercial came out, LA Golf came out with a series of 5 drivers designed for different clubhead speeds. It was not surprising that they all had different lofts, but it was very gratifying to me that they all had different face curvatures in more or less the way that that I had suggested. So this gear effect analysis keeps coming back to haunt me in a good way, and did all that with my knowledge of computers and program. Okay, let's move on. And I use the computer and computer networking to document my results. I have a website, and one of the tabs is golf, and probably 80% of the content on the site is under that tab. I have everything from beginner's stuff to you got to know engineering and second order differential equations to follow it. And you know, there's something for everybody there. Finally, I am currently the the title is Vice President of Engineering and Design for a company that makes putters. We're a small startup, so that means I am the designer and the engineer. And I was really pleased to see the power in a modern CAD program. I use it for all my design work. It can tell me exactly where my center of gravity is, what the moment of inertia of the club is, in addition to letting me model the design, produce drawings that the machinist can work from, and do photorealistic renderings. And I put together a video of let's get that one up, a video of a simple putter design. This is not anything as complex as Kelly and Co.Golf has in its stable. But here I'm using Fusion 360 from Autodesk. Okay. These are the folks who started out with AutoCAD. This is just a demo. And there are going to be some things missing. For instance, all these tools up on the top, for some reason, my screen capture program, I'm using Clipchamp from Microsoft.
Oh.
And
horrible
is right, but it was this week I went looking for something that I could capture the work that I was doing, and hey, it's Microsoft. I use Windows. What could be wrong? Well, it's horrible. None of the pull-down menus show, so I'll be waving this cursor in the demo at a non-existent pull-down menu or at a list down here of things that of the components and the pieces. Don't worry about it. Just pay attention to the kinds of things that the software is doing to the model. And that said, let's. This is a demo of me designing a putter head using Fusion 360. It is not a tutorial on how to use a Fusion 360. It is definitely not a tutorial on how to design putters.
Dave, I'm not seeing the video. I'm just seeing your that screen.
Nothing has happened yet.
Okay.
Just the cursor moving around.
Yeah, because you can't see anything pulling down.
And if you can't hear this, you can turn on captioning, closed captions in Zoom by going down to the bottom of your screen and the three dots under More, and then Show Captions. And that'll help you if you can't hear it well.
Dave, I have a question. What's your lowest and highest handicaps or index?
I never got into single digits. I was 10 point something for a while when I was around.
That's pretty good.
I was pleased with that. When I was in my low low 70s, yeah. In my early 70s. Low 70s is a really good golf score. I very seldom get there. These days, I'm sure I'm in the 20s because I've lost a lot of distance. But um, I try to play an appropriate set of tees. Anybody know what the Tee It Forward initiative is? I have an article about it on my website. If you're interested, go to my website and look it up.
I still use the whites, but
I use the 5,000 yard tees, whatever color they are.
Okay.
That Tee It Forward says you should base it on your driving distance, and based on your driving distance, you should go to our table, and here's the total length of the course should be. So for my driving distance, actually, I've lost some distance since then. I probably want about a 4,700 or 4,800, but I can still occasionally shoot my age at 5,000 yards. So that's what I play.
Can I ask your age?
84.
Okay. Very good. We have a guy I run a golf club. We go on 8 bus trips a year, 1-day bus trips to Pennsylvania around here. We're in Jersey. And this guy 2 years older than me, he can still shoot his age once in a while. And he's 78. And he finally got his first hole in one this year. He's got 12 eagles on par fours, though, which is, that's
amazing
distance, right?
That's amazing. Well, it means you had a good enough approach shot to hole out.
Yeah.
Well, and to put things in perspective for those that aren't out on the golf course much, one of the statistics that I had seen, you're talking about being 78 and shooting your age, and Mike's buddy, being down in the 70s, 80s, 10 handicap, things of that nature. I saw a statistic a few years ago, something like 90% of casual golfers do not break 100, do not consistently break 100. And I'd have to agree with it.
That is probably true.
Yeah, I agree. But wait, you talking about the ones that count all the strokes?
Oh, forget about that. I'm talking a legitimate.
I got guys in my club. The best wood in their bag is the pencil.
Oh yeah.
No, the other end of the pencil.
Yeah. Lowest way to lower your scores with an eraser. I went out and one guy in our group would consistently, I shot low score. Well, we were playing, inside the grip is a gimme. Again, the non-golfers, basically the length of a putter grip. So if you're a foot and a half away from the hole, pick the ball up. But you also count that as a stroke. Well, anytime he picked up, he never counted it as a stroke.
Right. I know those kind of guys too.
Yeah.
But we're always playing for some sort of prize money. It's not a lot, so you really need to count every stroke. Because I've seen guys miss 1 foot putts. Yeah.
Hey, Dave, just to go back to the technical side of things, you're talking about gear effect. Years ago, I remember a guy at work looking for new golf clubs, and we stumbled across, I think it was with GolfWorks, Roger Maltby's Maltby Playability Factor. where
Yep.
he ranked all the clubs. Can you talk about
Yeah,
that a little bit?
I know about that. Basically, he's picked on a bunch of interesting design parameters that make a club easier to hit. And he's gotten he's measured, I wouldn't say almost every club on the market because I haven't gone through his list thoroughly enough to know that, but he's measured an awful lot of clubs, his own and also all the popular brands. And
Yeah, it seemed like there was some sort of analysis going on behind the scenes rather than oh, well, I like this one or I like that one.
he was doing things like loft, center of gravity placement, shaft flag. There were just probably 10 or 12 parameters that he felt made a club easier to play or harder to play. And he would measure those and had this big old weighted sum to come up with the playability factor.
But how do regular guys that are, figure that out? What clubs should we buy?
Well, read his, go do a search on Maltby playability
Okay,
factor.
no problem.
And you'll see he gives instructions. If you golf like this, you should be looking for a playability factor in this range. And then you go through all his tables and he'll tell you what the playability factor of every club he's measured is.
And I don't know how much, again, as a hack weekender, and I haven't played in quite a while, when I bought my first set probably 30 years ago, I did all the reading, all the research, talked to all kinds of people, cast versus forged, and this brand versus that, and wood versus metalwood. And I worked with a guy who I actually caddied for over at Rumson Country Club when he played in the state mid-am. He was carrying a 4.2 index. So this was real golf. And I talked to him. What's the, this versus that, and his very good advice at that time was, forget about cast versus forged versus this. You got to like what you're looking at. And he turned out to be right. When you're starting off, if you're not at a professional level, at a higher level, it doesn't matter what the brand is, what the sales material says,
or the golf
like
ball.
Right. I'm not going to hit a ball out of a $50 Titleist 4 Pro V doesn't any further than I'm going to hit an X out. That's just the reality of it.
By the way, the difference is not the difference between the balls is not going to be very much in distance. Most of it is going to be in spin and handling around the green. And you're right, a beginner is not going to be able to spin the ball at will anyway, no matter what ball they've got.
Right, a hack weekender. I'd love to be able to walk off and blame every bad putt on the ball. But
well, if it's sufficiently round, the blame is well placed.
Oh, is that the problem? It's got to be round.
Don't use those dodecahedral balls.
Oh. It's the original form of recycling.
I never bought a Pro V1, but I sure have played with a lot that I found in the woods looking for mine.
Yeah,
Yep.
It's the original form of recycling. You put it in the woods, somebody else picks it up. You put it in the water, somebody else is going to grab it.
I have not bought a new ball in more than 30 years. Eventually, you get to the point where you find more than you lose.
Yeah, but I hope you're not one of those people that I have a whole bunch of bad words for. When you spend 10 minutes at the edge of the woods looking for balls. Holding up the group behind
Oh,
you.
no.
If I'm holding up the group behind me, no, I won't do that. If I'm
Right.
waiting for the group ahead of me, I sure will.
Oh, absolutely.
We have T-shirts in our group, BG, that says BGF on the side. That means bad golf fast.
I like it. I definitely like. By the way, my experience has been playing slow doesn't make you any better, and it might make you worse.
I agree, but I got guys in this. I got 80 guys in this club at at the mountains, and some of them are like, "Oh,
Glacial.
yeah, like the pros."
They should. Well, why don't we continue this discussion after the video has ended, because it's going to take some time.
Go for it.
Okay,
Okay.
I'm done. I'm done interrupting. Sorry.
To make a putter that's 4.8 inches long, that's the blade from heel to toe. The floor plan that's from face to back is 1.25 inches deep, and it's 1 inch tall. So let's work with half a putter head as long as we can, because we're going to try to make something symmetrical. So we will make just from the center to the heel. We'll build as much symmetrical as we can, and then we will go ahead and make it a full putter head and finish from there. So we're going to start with a block, a rectangular block of stainless steel. Let's create a box. We're going to do the rectangular floor.
Dave, I can hardly hear what they're saying.
Plus the.
That's why I recommended that you turn on closed captions. I had that problem when we rehearsed this as well.
I don't see where I can turn on. I see where the three dots are where they say more, but I don't see where it says.
If you go to the bottom, move your
Yeah.
cursor to the bottom, the
Right.
three dots,
Right.
more, and then hide captions, upper left, show captions.
I don't see that.
There's three.
Oh,
There's
I
three.
see. Show captions. Okay. Okay. Okay, I got it.
Sorry for the interruption.
Got it.
So here's the rectangle we're building. By the way, I just found out that my volume control also helps. Now we're sort of in the right scale. So this should be 2.4. So we've got 2.4 this way, 1.25 that way, and 1 inch tall. There we go. And I'll hit enter, and we now have our starting block. And we're going to use the famous joke about start with a huge piece of stone and chip away anything that doesn't look like an elephant. We're going to start with a block of stainless steel and chip away anything that doesn't look like the heel half of a putter. Let's start by going around in the back and cutting out a cavity which will create the bumpers and the flange. And we do this by making a sketch. So create sketch, we'll create it on this face, which is the back of the putter. And we're going to make a rectangle that will give us proper bumpers and a proper height. I worked that out as being 0.85 for the height and 1.4. Let's see if we'll just put it in 1.4. So we've got that rectangle, and we're going to use that to cut out a cavity, but it would be nice if we could make that somewhat rounded here. So let's modify fillet. And you can see that red line there. When I go to this corner, it's going to make a fillet there. And we can make the fillet whatever we want. I want it to be 1/4 inch. And this looks like something nice to cut into the back that will make it look a little bit more like half a putter. So we'll say that's a finished sketch, and now let's extrude. We will extrude that shape we just did. If we extrude this way, it's going to give us a new body, but we want to extrude this way and cut into the shape that we've got. And we want to go one inch deep, and that's what we've got. And let's say, okay, this is starting to look like half a putter. The bumper over here looks like just entirely too much material and ugly and square. So let's put a nice shape into that. Let's build a sketch here, and we'll cut across it. And we're going to put a rectangle here. And we want that to be 1 inch by 0.2 inches is probably a good size. That should trim it down a little bit, and let's get a pretty little curve in there. So a circle of 1.0 diameter, create a circle. From here, 1 inch, do that. So we have a shape here that we can cut out of the bumper. And we will extrude again. Extrude this and this and this. And the rest of it isn't part of the block. We could click this, but it won't cut anything. So let's go ahead and cut. And that's a reasonably attractive bumper. We might want this edge to be a little bit more attractive. Let's round it like 0.3. So modify, fillet, and 0.3 inches. There we go. That's fairly attractive. Okay, we're about ready to mirror. Oh, let's put some relief on the trailing edge here. We'll make a chamfer for relief. We're going to chamfer this edge, and it's given us the choice of not doing a 45-degree chamfer, but having separate cuts this way and this way. So we'll make this one 1/4 of an inch into the sole, and it starts assuming a 45-degree chamfer, but now we're going to tell it that this one is less. This is just going to be 0.07 inches. And that looks roughly like a relief chamfer. So we will accept it. And let's round the rest of the bottom. Edge here wants something like a 0.2 inch round. Let's do it around 0.2 inches. That looks good. And we probably want to put a bit of relief rounding on the front. We don't want nearly as much as we put on the side there, probably less than an inch, less than 1/10 of an inch rather. Let's say 0.07. Looks pretty. Okay, this kind of looks like half of a putter, or half a putter head. So let's go ahead and take this and mirror it. Create a mirror. It's going to ask us to select what objects we want to mirror. So let's mirror this chunk of stainless steel. And where's our mirror plane? This is a good mirror plane. And that does look like what we want to have. So let's say okay. And here we have sort of a putter head. Now we can, oh, we forgot something important, didn't we? How does the shaft attach? We need to do some sort of hosel, which is a structure that has a hole in it for the shaft to be inserted. And let's assume that we're going to be using a bent putter shaft, say a double bend shaft, so we can do a vertical hole to hold the shaft. So we'll put a cylinder right here where at the heel. We'll make the cylinder big enough to drill a hole for the shaft. Let's do another sketch. And we will do it on the top line here so that we can build a cylinder. And we'll do a circle. We'll have the circle start right here, and we'll have it be 1/2 inch, because I happen to know that 1/2 inch is big enough to contain a hole for the shaft. And we'll extrude the circle down. Now it thinks it wants to cut, and we know we don't want to cut. We want a join of a body. So instead of cut, we will change this to join. And now we can see we've got our cylinder. Let's go with that. Okay, this should be enough of a platform to drill our hole. So here's our drill tool, create, and it wants us to place a point for the center, and I don't see a point there. So let's cancel this and create a point. We can construct a point at the center of a circle, and the circle that we want is the one we just drew. And notice how that point just popped up. Let's undo it and redo it again so you can see that. I'm going to click this and watch the point pop up. There it goes. And now we can drill a hole. So the first thing it wants is the sketch point for the hole. So it's given us a little circle there and shown us that it's drilling down. That's sort of what we want. Now let's start setting the dimensions. And every club maker knows that, by the way, the things like setting the dimensions are off on the side here. And there are two things preventing you from seeing it. One is the participants over on the right. The other is Clipchamp just isn't showing that particular block of text. For an iron or a putter shaft, it has a 0.370 inch dimension, diameter. So you want a couple of thousandths of clearance. So that's 0.372. Notice how the hole expanded to about the size of a shaft. Now we probably want this to be about 7/10 of an inch deep. There we go. You can see the hole has gone down that much. An ordinary drilled hole, straight, everything pretty much straightforward. So we'll say okay. And now we have the hosel. So this looks like a putter head. We can, something I forgot, and I have seen actual club manufacturers, big club manufacturers forget this. You want to protect the shaft from this sharp edge at the top of the hole. So you do what is known as coning the hole, and it's easy to do in Fusion 360. We'll just chamfer that circle right there. We will make that 0.08 inches. No, that's the wrong one. That's 0.02 inches we want that way. And then the other one we want 0.08 inches. That's fine. So now if we look closely, we have that cone shape protecting the shaft from the sharp edge. Now, all that remains is to round some edges that are a little bit too sharp right now. And we don't want to do an awful lot of the rounding, probably 0.02 inches everywhere. So let's say modify fillet is going to give us rounding. And let's round a number of these. We'll round this. We'll round this. Those are probably some that we want rounded. We said 0.02. Okay, that was enough to get the edge off. Probably a few more that we want to round. Let's do some more fillets. Here, 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 here. We'll do 0.02 again. And we can say okay. And we have a nice should be a nice putter head. Now, when I want to, I'm the designer for this company. When I want to send this to our salespeople, our salesperson, to see if that's what they think they can sell, they sometimes have comments on it. I want something a little bit prettier than this. And I can actually go change from design mode to render mode. And it gets a whole lot prettier. And as a matter, it starts to look like stainless steel. And if I want a photorealistic rendering, I can even get that. Invoke the in-canvas renderer and see what it does. This takes a while, so I'm probably going to jump it forward. Actually, NVIDIA had a good run of profits building chips that made this process, graphic rendering, a whole lot faster. My computer does not have a bunch of NVIDIA chips in it, so this is slow. And then they lucked into making it big in AI because AI chips needed the same special characteristics that graphics chips did. Okay, this is about as good as it's going to get. And that's the end of my talk.
You get an attaboy.
Is there... Okay, I can end sharing, right?
Yes, if you want to stop your sharing, then you'll be on the screen. And
yes, and that's what I want to.
how much does Fusion X360 cost?
It's a subscription. It costs almost $700 a year. It is a professional tool.
I'd like to make a comment about the stuff about the bubble on the shaft.
Yes.
Did you see that recently there was in baseball a reevaluation of the bat in which they determined exactly that kind of thing for the baseball bat? And they ended up reshaping the baseball bat. I think they call it a torpedo bat now, where the weight is further toward the away from the batter's hands, and they made it a little bit bigger, still regulation.
Mickey, are you still there?
Carol? Mickey.
Yeah, Mickey is on Carol's
Yeah.
He's currently muted and has the thing turned off. Let me ask him to unmute. See what happens.
If you press space.
There. Can you hear me now?
Yes.
Yeah.
Okay.
So, do you have
I just
anything
heard
to
what
say
John said about redesigning a baseball bat. So I hadn't heard that before, but I think it's something you should be doing.
Mickey, you're the baseball expert.
Yeah, you probably can find a YouTube video about that. I remember seeing the whole thing being discussed.
Right.
They did evaluations by doing the same kind of thing that, what was it, TrackMan did, because in baseball, they have these cameras everywhere watching the batter and the ball and everything. And so they monitored a whole lot of batters and saw which things seemed to make a difference. And then they did the analysis the way you did and reshaped the bat. And they had to work so that it was still a regulation size bat.
Right. So did they find differences in how far the ball would go, or?
Oh yes,
Yeah.
yes.
But it might work better with metal bats, like in college and little league and stuff like that, because a metal bat's probably more like a golf club than a wood bat.
I think that the same effect occurs whether it's a wooden bat or a metal bat, but I don't recall. But
John, did this affect how quickly you could bring the bat around?
No, it affected how the bat, where the power of the bat was with respect to the ball.
Okay.
Apparently, it has to do with the coefficient of restitution of the ball being struck by the bat. How much momentum is transferred.
Yeah,
Sounds very interesting. I'm gonna go, I'll take a look to see it, on YouTube. Yeah. By the way, I should just say that in my time, which was a long time ago, the biggest bat in baseball was used by Moose Skowron. And I got to have one of the bats that he used because my coach in high school, I was in high school at James Monroe in the Bronx, and my coach was a close friend of Hank Bauer. So whenever the Yankees had a bat that was chipped a little bit or whatnot, he would give it to the coach, and the coach would bring it to us, and we'd use it in the game. And I like the Yogi Berra model personally, but I did try to use the Moose Scouring bat. I couldn't get it around quick enough. It was just too big and heavy. So just adding that in. That's all.
So this thing is called a torpedo bat, and you can search for designing or reshaping a torpedo baseball bat on YouTube, and there's a whole bunch of
Okay.
videos.
Thank you for that. That's very interesting.
So that was similar to what you did in that very early analysis. You did that 20 years ago. That was
30
great.
30 years.
But I want to ask you one question: walking or taking a cart? Do you walk or you take a cart?
I hate riding. I love walking. What I have found that keeps me on the course is motorized wheels on my golf cart.
Yeah, I have that too. Yeah.
Okay.
We're still here for a little while for any other questions. People interested in, so the computer, even from the earliest days, gave you the ability to do these computations, is one of the things that I got.
Yes.
But again, you needed to understand a lot of the engineering to be able to.
The computer can't do the engineering automatically, or it couldn't. I have no idea how long it's going to take before AI is going to figure out how to do what I do. Well, thank you all for paying attention, and it was fun.